This video is about the area of regular polygons.
Okay, so in a regular polygon, like a pentagon or hexagon, octagon, those types of shapes, there are two special lengths that you're going to need to know the name and location of. One of them is called the radius, and one of them is called the apothem. This is a picture of a hexagon inscribed inside of a circle. The reason we've put it inside of a circle is so you can see why we would name the segment that goes from the center out to one of the vertices a radius. So just like as if it was a circle, the radius of the circle starts from the center and goes out to the circumference of the circle. And the radius of a regular polygon starts from the center and goes to a vertex, which is different from the apothem. The apothem starts at the center and goes down to the midpoint of one of the sides. Now, in a regular polygon, there are going to be as many radii as there are vertices. So in a hexagon, there would be 6 radii. In an octagon, there would be 8. And same with apothems. There will be as many as there are sides. So there are going to be 6 apothems here. Because you can imagine dividing like a hexagon into 6 equal triangles. The reason these definitions are going to matter, they're going to matter a little bit more later on when we learn some trigonometry. But one of these words particularly, which is the apothem, is going to show up in the formula for the area of a polygon. So another thing that's going to become important, again, more when we do the trig, but it's worth looking at now because you have the skills to do it now, is to find missing angle measurements inside of a regular polygon. So this is a picture of a regular pentagon. I have 3 angles that are labeled 1, 2, and 3. And you need to be able to figure out the degree measurement of those with only the information that you're looking at now. So knowing that this is a regular polygon, we can determine angle 1 because we know that we've divided our pentagon into 5 equal pieces. And if you think about this as being a full circle here, angle 1 is 1/5 of that circle. Circles are 360 degrees, so we can easily find the measure of angle 1 by taking 360 degrees and dividing it by 5, because there are 5 equal triangles within this pentagon. So 360 divided by 5 is going to give us 72 degrees for angle 1. And once we know that that's 72, right here, we can figure out angle 2, because angle 2 is simply going to be half of that. Here is another 72-degree angle, and that's been bisected by the apothem that's drawn here. So that apothem comes and bisects another 72-degree angle. So the measure of angle 2 is going to be half of 72, which is 36 degrees. And then the measure of angle 3 we're going to figure out by using the triangle. I see a right triangle right here that I can use, which has a 90-degree angle, a 36-degree angle, and angle 3 as the missing piece. The triangles have to add up to 180. So the measure of angle 3 is going to equal 54 degrees. So it's worth practicing now because you have the skills to do it. So it's going to be on the worksheet that goes with this lesson. But again, it's going to be more important later when we jump into the trigonometry to be able to identify the size of all those angles. Just so you see where this formula is coming from. If you have a regular polygon, you can divide it up into equal triangles, as we've seen and talked about here. And you already know that the area of a triangle is going to be 1/2 base times height. Based on the picture I've shown here, the base of this triangle we can call S. S here stands for the side of the pentagon or octagon or hexagon. And the height of the triangle shown here is A. A stands for the apothem of the pentagon or hexagon or octagon. And so this gets you the area of one of the triangles inside of this shape. If I wanted to then scale it up so I could get the area of the entire figure that goes all the way around, I'm just going to need to know how many of those equal-sized triangles there are in the whole polygon. So the number of those triangles, of course, is equal to the number of sides. So if there was a pentagon, there's going to be 5 of those triangles. Hexagon, there would be 6 of those triangles, and so on. So you end up multiplying it by the number of sides. This formula is the formula for the area of a regular polygon, except for that multiplying s times n, if you think about it, is the same as saying this plus this plus this plus this plus this, and what we're describing here is basically the perimeter of the shape. So you'll see that instead of being written as 1/2 apothem times the side times n, it's written as 1/2 apothem times the perimeter. So there's the formula that we're going to be using to get the area of a regular polygon. Half the product of the apothem and the perimeter of the shape. And now let's use it. We have a regular, we have to count up the sides here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided shape, regular decagon. We have labeled an 8 along one of the sides. We have labeled the 12.3. We want to double check that that 12.3 that they gave us is the apothem and not the radius. Indeed, it goes from the center to one of the midpoints, so it is the apothem. So we'll start with our formula, area equals 1/2 apothem perimeter. We'll fill in the apothem. The perimeter for this shape is going to be 8 times the number of sides, which is 10. And then we can take out a calculator and get the area of this decagon, which comes out to 492, and the units here would be inches squared. It's definitely easier to use that formula than to try to get one of the triangles and then multiply it by however many there are. It's a straightforward formula, should be a pretty simple assignment. And that is all.